In this video, I'll show you how I made a wireless water tank monitoring UI using the Elecrow 2.4-inch ESP32 S3 board with a LoRa module. This board supports interchangeable wireless modules, making it easy to meet different communication requirements, such as the ESP32H2 for Thread, Zigbee, and Matter, the ESP32C6 for Wi-Fi 6, and the NRF24L01 for 2.4 GHz wireless communication. All the board details can be found on the Elecrow product page. The wiki page is also very helpful for getting started. For the LoRa sender, I'm using the M5 Stack Cardputer Advanced. Currently, it's sending only mock data, but any sensor can be added later, which I plan to do in the future. Elecrow also sent some nice rotary displays. I'll create something interesting with them soon. You can find the LVGL template on my GitHub, and I'll be adding more soon. If you'd like to see more integrations with displays and Home Assistant, you can support me on Buy Me a Coffee. Before we jump into today's video, a quick message from the sponsor, GoLogin. It's basically an anti-detect browser that lets you run multiple accounts on one device without getting blocked, flagged, or doing all that annoying password transferring. GoLogin isn't just about staying private, it gives you real freedom and control online. You can unblock any content, stay completely off the radar, manage multiple accounts smoothly, and a whole lot more. If you want privacy, security, and complete online freedom, GoLogin is the tool you need. Give it a try for free. Links in the description. The UI is simple. I use a slider to show the water level, and I created 3 images for the main part, the indicator part, and the knob part. I used Google Gemini Nano Banana to create the images. Then I styled the slider widget using the appropriate images, and I added a few more images to refine the UI. For the label, I placed it inside a panel and used a flex layout to position everything neatly. For the battery indicator, the bar is aligned with the battery image, along with a label. Once I was satisfied, I exported the UI. Then I copied the exported UI to the lib folder of the template project. I opened the template project in VS Code, then built and uploaded it. The UI is ready. For the receiver, I defined the LoRa pins based on the factory code. Using the same method, I set up the pins for the sender. I generate dummy sensor data to simulate water level, pH, temperature, and battery. In setup, I create the first dummy data and prepare the initial data packet, then send it over LoRa to start the process. In the loop, after each transmission finishes, I generate new dummy data, prepare a new data packet, and send it again, continuously updating the display with the latest values. This dummy data can be easily replaced with real sensor readings. For the receiver, I initialize sensor data in SPI, then reset and configure the LoRa module in Begin. In Receive, I check for incoming packets, parse the data into sensor values, validate it, and update the timestamp. This lets the receiver continuously get and process sensor data from the sender. I update the UI by setting the slider and labels based on the sensor data. The water level updates the slider and shows percentage and volume. This keeps the display in sync with the latest sensor readings. Finally, I integrated the receiver in main.cpp by creating a LoRa receiver instance. In setup, I initialize it with Begin. In loop, I check for new data, and whenever it arrives, I update the UI. Finally, I open the sender and receiver separately in VS Code, since each uses a different board setup, and then flash the respective code to each device. If you enjoyed this video, consider supporting by liking, commenting, and sharing. Every little bit helps.